Statistics underpins virtually everything that data scientists and analysts do in their roles. So why is learning it always made so tedious? Think of a statistics textbook. Heavy, hard, bland, and boring. This series of videos is going to be the opposite. I'm going to run you through the most important statistical concepts that you'll need in your data science and analytics careers, and it's going to be interesting, intuitive, and fun. We'll cover different types of data, statistical distributions, so normal distributions, t-distributions, binomial and Bernoulli distributions, uniform distributions, and the Poisson distribution. We'll take a look at the very powerful central limit theorem. We'll look at confidence intervals, 4 types of hypothesis tests that are just vital to know. We'll cover off exactly what a p-value is and what it is not, and we will cover off statistical notation. Now, if any of that sounds scary, do not worry. Like I said, this series is going to be as intuitive and illustrative as possible, ensuring that you feel comfortable and confident using all of this in your career. So kicking off now in part 1, we're going to start right at the top, and I'm going to show you the types of data you will come across. This will give you the foundation you need to move on to the advanced concepts in part 2 and beyond. So let's do this. At a high level, we can break data down into 2 main types. Firstly, numeric data, or what is sometimes referred to as quantitative data, and then secondly, categorical data, which in the same way is sometimes referred to as qualitative data. Numeric data can be broken down again into continuous numeric data and discrete numeric data. Similarly, categorical data can be broken further into nominal data and ordinal data. So what are the differences between each of these types? Well, let's say we worked for the sportswear company Nike. Let's discuss some examples that we might come across while working for Nike to show the differences between these data types. So over on the left with continuous numeric data, this would be a data point such as the height of one of our sponsored athletes, basketball player LeBron James. Now, LeBron is pretty tall at 2.06 meters, but what is it about this measurement that makes this value of 2.06 continuous data? Well, continuous data exists in what is known as fractional form. This means that it represents information that can be divided to a more granular level. In other words, while LeBron here is listed as being 2.06 meters tall, if we had some high-tech distance measuring device at our disposal, we might find that he is actually 2.064759 meters tall. The key thing to remember here is that continuous numeric data has an infinite number of possible values within it. So other examples of this could be the speed of a truck, or the time taken for somebody to run a race, or the size of a room. Each of these measurements can be broken down further and further. So that is continuous numeric data. What about our next one there, discrete numeric data? How and why is that different? Well, there is a distinct and important difference. An example of a discrete data point would be something like this here. The number of goals scored this season by another one of our sponsored athletes, football or soccer player Cristiano Ronaldo. He has scored 38 goals so far this season, and unlike LeBron James's height, this value, it can't be broken down any further. There are no half or quarter goals. And that really is the difference. Where continuous numeric data could be divided or made more granular, discrete numeric data is essentially counted data using whole numbers. Other examples could be the number of students in a school, the number of entrants in a competition, or the number of days in a year. So that is a quick overview of numeric data. Let's head over to the right of screen there and take a look at categorical data, and specifically the differences between nominal and ordinal categorical data. And funnily enough, the way I remember what nominal categorical data is that it isn't ordinal. And this might become a bit clearer in a moment. So nominal data essentially has no order to it. And while continuing to put ourselves in the shoes of sportswear company Nike, an example of this might be a list of our competitors in the sportswear industry. Here we have Adidas, Under Armour, and Reebok. It's just a list of names or categories without any one of those being greater or smaller or better or worse than the others. Other examples could be people's first names, countries, or the names of colors. So the key thing to remember is that nominal data doesn't have an order to it. And of course, this leads us nicely to ordinal categorical data, which is where we again have categories or classes, but there is an underlying order to them. And again, if we're Nike, an example of this might be something like the sizes of a new line of t-shirts that we're launching. So medium is bigger than small, large is bigger than medium, and much bigger than small, and so on. While they're categories, there is an inherent order within them. Other examples of ordinal categorical data could be good, average, bad values for customer satisfaction, or letter grades for an exam result of A, B, C, D, or F. So there you go. That is a nice high-level overview of the different types of data that you'll often come across in a career within data science and analytics. And now we've looked at this, in part 2 of this series, we are going to take the next step. In part 1 here, we discussed that LeBron James is approximately 2.06 meters tall. And while this might seem very tall to you or I, we need some more context. We want to understand how this compares to the heights of all players in the NBA. And we will do this by discussing something called a distribution. Distributions are an extremely important concept to know about and to understand. So let's do it. Let's discuss this in more detail in part 2 of this series. I will see you there.